All right, today we're going to learn about logarithms. And that's just going to be a quick review for you guys because we had them last year in Algebra 2. And now you're in pre-calculus, okay? So just a quick review. Log functions are reciprocal functions of exponential functions, okay? And if you recall, we can convert a log function to an exponential function using the circle method. For example, right here, okay? Log base 4 of 16 equals 2. We can convert that to an exponential by saying 4 squared equals 16, which obviously is true. And in this example here, we can say that 2 cubed equals x. Well, in that case, we know that x is equal to 8, because 2 cubed is 8. Okay? So that's just a quick review of the circle method. All right, so if we want to rewrite these in logarithmic form, okay, here's our base. So we can say the log base 10 of 100 is equal to 2. And if we check it using the circle method, we can say 10 squared equals 100, which is what we have right here. Okay? We're just going to fly right through this. Okay? All right. We don't need to worry about that. Now let's go to expanding logarithms. All right, properties of logarithms. Okay, if you recall, we have the product property, quotient property, and the power property. And those are the three properties that will get us through logarithms, and especially logarithmic equations, okay? So for example, using the product property, if I have the log of 2x, and I wanted to expand that, I can rewrite it as the log of 2 plus the log of x. Because 2 times x converts to log of 2 plus the log of x according to the product property. Okay? Now the quotient property uses subtraction. So using our same example, the log of 2 divided by x equals the log of 2 minus the log of x. Okay? So that is the quotient property. Now, the power property is a little bit different. It just takes whatever power you're raising something to and pulls it out front. So let me give you an example of that. So let's say we have the log of x cubed. Excuse me. If we want to, again, we're talking about expanding the logarithm. We would pull the exponent, which in this case is 3, pull it out front. So we would write 3 log x. Okay? Another example. Let's say we had the log of 2x cubed y squared. Excuse me, that's a little bit more lengthy, okay? So we just go a step at a time. We have log of 2, which is right here, plus, because these are being multiplied, these right here are being multiplied. 3 log of x plus 2 log y. All right? So that is expanding. Now let's look at one where we have some subtraction and using the quotient property. Let's say we have log of 3x squared divided by y. That would expand to log of 3 plus 2, because of this exponent right here, log of x divided by, we can put it over the whole thing here, log of y. Okay? And that's going to be really helpful when we start talking about equations. Okay, so let's do an example here. Okay? If we want to write that now as a single logarithm, we're doing what's called condensing. So before we were expanding, in other words, we were stretching it out, excuse me, and now we're condensing. Okay? So we've got, this would become right here, problem A, log base 4, the base doesn't change, okay, of 32, and since we're subtracting, that becomes dividing over 2, okay? Then that simplifies to log base 4 of 16, because 32 divided by 2 is 16, and then this we can actually go a little bit further. Okay, some people want you to, and some it's not a big problem. But log base 4 of 16 is actually equal to 2. Okay, because 4 squared is equal to 16. Okay, now let's look at this example right here, example B. Okay, here we have an exponent involved at these two spots here. Okay, so again, we keep the base the same. Log base 2, x to the 6th, and plus, so that means subtract y to the 5th. And there we've condensed it down into a single logarithm. Okay, there's some more examples. Now let's look at expanding A here, okay? So we can say the log of 4 plus the log of x subtract the log of y. Because here, these are being multiplied, and this is divided, so that becomes subtract. Okay? And there's really, when you're expanding, there's really no oversimplification you can do with that. Now, let's talk about change of base formula, okay? Which I will write as change of base. And it is very, very handy. And it lets you convert into one single term. So let's say the property here is log base b of m is equal to the log of m divided by the log of b, okay? Now what that means, it's easier to show you an example. Right here, the log base 81 of 27, okay? Log base 81 of 27, okay? We can rewrite that as the log of 81 divided by the log of 27, okay? And then you put that in your calculator, and you're going to get 0.75 or 3/4. Now, this first method they're using here is called the common base method. And if you just want to use change of base, and you don't have a problem with getting a decimal, I'm not real concerned with using a common base, okay? Because you notice the answers are the same. Again, this is pre-calculus, and we're just reviewing this, okay? So, we're not gonna get into too much detail, because you've already had this. Okay, so example here, we can write log of 8 over the log 32. Okay? Now, just a note, you could put this in your calculator because our base is 10. Okay? And that's called a common logarithm, common log. And a common log has a base of 10. And that's really the only log you can use in your calculator without getting into anything too complicated. Okay? So if we use the change of base here, we have the log of 18 divided by the log of 4. All right. I think that should do that. Now let's go and look at a different topic since we're just reviewing. All right, let's look at exponential and logarithmic equations. Okay? What is the solution of 16 to the 3x power equals 8? Okay? Well, we can use logarithms to solve that. And really, when you're trying to solve for a variable in the exponent position, you really need to use logs. Okay, that's why they're very, very helpful. One of the reasons, anyway. Okay, so if we use expansion and expand this out, we'll see what we get here. So we have 3x times the log of 16 equals 8. Okay? Now you notice I took the log of this side. So really, according to the golden rule of algebra, what you do to one side, you have to do the other, right? So I didn't take the log of that side. So we have to do that. 3x log of 16 equals log of 8. Okay? So now we can just divide by log 16. Okay? Then we get, move it up here a little bit. Three x equals log of 8 divided by log of 16. Okay? Then if we take the log of 8 divided by log of 16, and then we can divide the whole thing by 3, and I didn't grab my calculator, so I'm not sure what that's going to be equal to. All right, so that is how we can use logs to solve equations.